Today I'm going to talk through PDF and Office document formats. So Homework 1 had a nice introduction to building malicious PDFs, and some of you may have also taken the jump to actually go and analyze some of the content of your PDF that was created by Metasploit. So this lecture, we'll start off with talking through the PDF file format a little bit more. How it's structured, how it works, kind of how a lot of attackers take advantage of some of the features in it to exploit a PDF reader. Similarly, we'll also talk about the Microsoft Office file formats, which are, no surprise, different from the PDF file format. They have a much different structure and a much different concept to how they do document presentation. The reason I picked these two is because outside of exe files and stuff like that, these two end up being very common attack vectors because mainly because they interact with very complicated applications. So very complicated applications tend to be comprised of lots of source code. Lots of source code tends to be more likely to have at least one vulnerability in it than small amounts of source code. So it's kind of the way I look at it is, as quantity of source code increases, the probability of an exploitable vulnerability also increases. So that's the case with both of these. They also tend to be programs that are installed on every single business computer. So when you're talking about maximum kind of attack surface, maximum target, these two file formats are pretty good ground assumptions for, for their existence on any computer. So we'll start off with the PDF document. So I think it was like during week 2 or so, we looked at PDF documents a little bit. So, and then of course you all had them during the assignment, during Homework 1. So PDF documents, they're intended to be a printer representation or final copy of a document prepared for digital viewing. So the idea with a PDF is that it's supposed to describe to a printer how to lay out your content on pages, So this is in contrast to Microsoft Office, which typically the job for that is trying to provide a nice visual view of editable text. This one is almost always, or I should say always, a kind of printer representation. There's some additional features in PDF that allow you to maybe add content after the fact, but a lot of times those are using like the, this feature right here, the Forms UI. And so that's generally speaking supposed to simulate maybe a printed document that has vacant fields that you would write in, but in a digital form. So usually when it comes to editing after production, PDF generally leaves that just to a handful of features. So this is a very important purpose because from the business perspective, it causes a lot of people to maybe assume a lot more safety around PDF documents. They assume them to be just a read-only document or something like that. They don't tend to realize that, number one, it's based in the PostScript language, which was originally designed for a lot of laser printers to use and stuff like that. And they don't realize that it has all these features. So if you're using PDF today, and we'll just pick on Acrobat Reader, all the versions of Acrobat Reader that I gave you to use implement either some or all of these things. And so, we can go down here. So the thing you call JavaScript is traditionally the ECMA language standard. PDFs actually have a PDF.js, which is basically a JavaScript with some assumptions built around it. They give you access to document components. The concept is very similar to how JavaScript is implemented in your web browser, where you can always presume that there's a document object, and then that document object has a number of methods you can call against it. If you write JavaScript for your web browser, all those objects don't exist if you're using the JavaScript command line tool, like Rhino or something like that. Same is true here, where the JavaScript interpreter that's built into Acrobat Reader and then is also presumed to exist in most PDF readers implements a number of objects that you can directly access that give you the ability to query certain document contents and things like that. So I mentioned the forms UI. So this is a way for querying the user for any sort of variable user input. Another interesting thing about this feature is that you can choose to pre-populate fields. You can choose to do certain things to user inputted text and things like that. So there's a lot of complexity there that allows it to be a good place to introduce some some exploitable vulnerabilities. Another one, because universal file format for sharing 3D model data was seen to be at one point to be a very valuable thing. Adobe decided to build these things, and I think they were actually sold as extensions to Acrobat Reader at some point, until eventually Acrobat Reader just incorporated both of them. And basically what this means is that you can go to a lot of the 3D modeling tools out there, the 3D modeling software, and actually have them embed an entire 3D model that gives you the ability to move it around and everything like that inside of your PDF. The goal here would be that someone would be able to look at your 3D model in a PDF without actually having the modeling software installed. So that basically embeds an entire 3D rendering engine into Acrobat Reader that may or may not interact with the 3D features of your video card, which again is another big piece of complexity that's added. It also happens to be originally third-party code, so code that was contributed to the Acrobat project by another source that may not have gone through the same testing mechanisms and everything. And so I pointed out here specifically because back in about, I think it was somewhere around 7 to 8 years ago, the introduction of this feature was the source of a large number of exploitable vulnerabilities in Acrobat Reader at the time. So another one is Inline Html. So just like in a web browser, they decided they wanted to replicate this behavior because it makes it easier for kind of code sharing and data sharing. You can actually just render HTML inside of the PDF document. So basically have it typeset HTML markup for you so that it looks kind of like what I've got on the slide here, which is rendered in a PDF. Numerous embedded image formats. So the goal here, of course, is trying to maximize compatibility and maximize utility. Which means that a whole bunch of the image formats like JPEG and GIF and TIFF and bitmap and a whole bunch of others are supported within here as well, which means that for any one of those image formats, if the commonly used image libraries have some sort of vulnerability in them, then that vulnerability naturally may also exist in any version of Acrobat Reader that also happens to use those libraries. You can store PDFs within PDFs and PDFs within PDFs within PDFs and things like that, which introduces a kind of additional container layer complexity. So you may actually have to analyze PDFs by extracting the content PDFs and then further analyzing those independently of the original one as well. So it's a good method to, for instance, obfuscating a PDF so that maybe standard signatures can't detect attacks built into it. And then encoded and encrypted stream data. So you'll remember that I mentioned that most of them have some or all of these features. In addition, many of these features may be used together. So for instance, the PDF within PDF would embed a PDF inside of a stream, and that stream itself could be encoded or encrypted. So it could be encoded with some sort of data obfuscation layer, or it could even be encrypted with a password. That password doesn't necessarily have to be something that the user inputs. PDF actually has the concept of a built-in encryption password or something like that. The goal being that the only tool that would be able to open that PDF, it's a real lightweight security measure, but the only tool that would be able to present that information to a user would be one of the authentic Adobe tools. Basically a tool that had hard-coded into it the decryption password for whatever encryption you wrote. So almost as a very lightweight digital rights management or something like that. But it supports that, and that functionality is very useful from a kind of data hiding or attack hiding perspective. So if you'll remember a few weeks back, I think it was like maybe about 2 or 3 weeks before spring break, we started talking about container file formats. We discussed the We discussed the image file formats and the PE file formats, and how you can almost kind of realize them as large containers, and in some cases ordered containers of certain subsets of data. And in the exe file format, you had certain types of header data, and that header actually contained other things. And then there was a part of the file that contained sections, and then there was a part of the file that contained resources and everything. So I'll try and use that as a recurring theme for a lot of the analysis that we do. In this case, I couldn't find as good a diagram for PDFs as I had for the PNG file format. But similar to the PNG file format, PDFs have the concept of basically multiple streams of data that can be variable length. The way that it usually works is PDF starts off with this literal text %PDF-number.number, which number 1 indicates it's a PDF file. So the beginning of the file has that. And then following that, there is some other header data as well that's usually included. And then other information can follow that that is basically skipped until you get to the first object data. And so then the document really just consists of a sequence of object references and object data. So it'll basically be repeated sequences of I list X, Y, and then W, Z up here, but those are basically placeholders for numbers. So the X and Y are usually represented as a number. A lot of times, I think the second one is most of the time 0 when I'm looking at these. But basically, it would be like 2 space 0 space OBJ. Whoops. And then that would be followed by a large kind of variable length block of object data until finally it runs into this end OBJ tag. So it uses plain text to do a lot of the object delineations. So then after end OBJ, it basically will skip data until it runs into another sequence that matches this pattern, number space OBJ. And then it'll start up another object data. So what's interesting about this is it gives the ability for the document to actually have other junk in between objects and things like that. One of the reasons for this is that, again, the file format is derived from PostScript, which was a language designed for explaining to like vector graphics output. So like laser printers, things like that, and even some terminals, how to present data on the screen, how to present information on the screen in a graphical format. Because it was written for that, and it's actually PostScript's really old. I think that it was originally introduced by the Xerox. Yeah, so it was part of Unix, or it was very popularly used in Unix. Originally introduced by Xerox, I believe, quite some time ago, or originally not introduced, used by Xerox in the Unix environment. Then I think Adobe has had it for quite some time, or Adobe is the one who introduced it. Anyhow, that said, there was a time when it would not be out of the ordinary for a human to actually write the PostScript data manually. And because of this, it became beneficial to have kind of very specific begin object, end object tags, because that way you could add commentary or maybe other information in between those if you needed. So basically you'd have a bunch of object data until finally you get down to what's called the Xref table or cross-reference table, which is literally an index of the object for each of the, or index of the offsets for each of these indirect objects. So, you know, these, you know, basically mark what are called indirect objects with a number and a number, with basically two numbers. And then this index actually just tells you where the offsets and the byte offsets are. And then finally, there's a trailer that contains a pointer or the offset to the Xref table. And then also a dictionary that defines the catalog, count of objects in the cross-reference table, and other information that might be viewer-specific. The idea being that different viewers get to pick and cherry pick and choose which items that they're going to pick out of these little tables. So from the perspective of a maybe one approach to analyzing this document from the machine point of view would be to look for the header first, and then once it's looked for the header, maybe it'll jump to the end of the file and then work its way up until it finds the trailer, and then it uses the trailer to find out where the cross-reference table is and the dictionary and all this other stuff, and then from there it would move up to the cross-reference table, index all those offsets, and then it would be able to jump around the file without necessarily having to maintain the entire file in local memory. So that might be one approach that a system uses to try and navigate this. So it itself is kind of a unique file format. Has a lot of features to it. And has a very kind of simple, overlay here, or a simple kind of outline for how to use it. This also means that there's a potential for a whole bunch of arbitrary, arbitrary data to put in. I'll say that also the other last piece that I'll add, I think, was like the start Xref, which I believe that's the that's like where it's telling where the cross-reference table starts. So later on, probably Thursday, we'll actually go into analyzing a PDF, and I'll pull maybe a few of them out, maybe even some of the ones that were generated by Metasploit, to show you how this is, how this kind of works, and how the tool, or I should say some of the tools that are useful for analyzing PDFs use this information to navigate them. But in a nutshell, this is the file format, and then it almost always ends in %EOF. One more thing I'll say that's interesting about this that I found from analyzing it is that Adobe Acrobat is notoriously error permissive. One of the other things that's worth keeping in mind with this is because it was originally meant to be like fed to printers and things like that, you might have really large amounts of PostScript that's fed to a printer over what's possibly a noisy channel. Noise on the line, introducing some maybe errors into some of these keys and everything. That's something that it appears some implementations like Adobe's actually handle gracefully. So for instance, I've found cases where some of the keywords, you only need some parts of the word to exist in order for a keyword to be matched, and other cases it can identify There's a lot of versions that'll recognize when a new object starts before another one ended and things like that. So it manages to gracefully recover from weird errors, which can also be a possible source of vulnerability. So, but from the user perspective, it maximizes the amount of PDFs that are actually like readable by you. So that's an important thing to keep in mind too. There's a big difference sometimes between how it actually ended up being implemented versus how the specification said to implement it. So we'll talk about the PDF objects now. So object data I mentioned up here. So just kind of jumping back, we're talking about things that fit into these two rows right here. Object data is basically any data beginning with the following text where X and Y are integers. PDF specification defines a number of data types. So again, PDF or PostScript, we'll talk about, just focus on it. I'll just use PDF from now on. Has a number of data types that are actually defined in the standard for objects. And so these objects would be kind of similar to how you would use variables in a programming language. They're generally, all of these types, with the exception of the streams at the bottom, are considered to be like the atomic native types of the interpreter. So you can have like Boolean values, numbers, strings. I have some examples of how these things are supposed to be represented inside of the document using the syntax. So for instance, strings is an interesting one. They represent strings by putting parentheses around it rather than like the quotation marks that you're familiar with. So they probably because there was a valuable reason for doing it this way, they have some deviation from what would be your normal convention. So names, character data beginning with a slash. So this has a distinction between strings and then also just kind of named objects or named entities, almost like enumerations. Some of you who may have been around when Pascal was still used might be familiar with how Pascal implemented enumerations. And so this is kind of I would say that's the closest analog to this. But the idea here is that it's not necessarily string data, but it's actually a named entity that then gets recognized as an object in and of itself. Or for lack to kind of do the reverse thing, strings you can do string operations on. You can break them up by character and stuff like that. You can perform string operations. Names are things that do not necessarily end up being interpreted as sequences of characters. So they exist for labeling purposes and things like that. And then also may refer to certain constants or certain properties that exist in excuse me, certain properties that exist within within the PDF interpreter or the PDF viewer. They're also a good way for doing enumerations, or I should say they'll also be used for enumerations as well. So arrays, so square brackets, so that's actually consistency. And then dictionaries uses these two, the double or the double angle brackets. So this is a good example here of how that name rather than a string is used as a key, and then the string is actually returned as a value, or in this case a list is returned as a value. So again, this is an example of the names being used as an enumeration almost. So they arbitrarily chose val1, val2 for this example. And so underneath the hood, those basically end up being some sort of enumerated, index or something like that. Streams, that's where pretty much all the visual data and all the content and everything like that is usually stored. So that itself ends up being an object type. And there will be a lot of analysis done to that, because that's the place where if you want to hide an exe file inside of a PDF document, a stream is a good place to do it. And then finally, null content. Just for whatever reason, similar to how Python has a none type, right? This has null type, or null content type. I don't know why. It is useful for implementing it. It might be useful, like if you think about it in this case, you could actually create a key, but have that key have a null content to it to say that it's empty. So again, it's a programming language, so it's an application-specific programming language, but it's still a programming language. So there's this PDF parser tool. I mentioned in Remnix, I believe I have this tool installed in Kali as well. It comes default, or I should say it comes built into the Remnix distribution. The version I have in Kali the version I put into the Kali VM might be a much newer version though. But it is helpful in navigating the document structure. So I have some real common recipes for using this tool for navigating the document here. You can feel free to play with these later on today and tomorrow. And if not, I'll be playing with these on Thursday. So in this case, what it tries to do is it gives you a programmatic interface to be able to navigate those different objects that are in the file. So as I said, and we'll go back up here so you can see it, you basically have these objects, and some PDFs may have hundreds of objects in them and stuff like that. This tool gives you a way to navigate those individual objects and even extract the stream data from them if they happen to be an object that represents a data stream. So in this case, the first one is search for data in an object. So it says it's looking for the string myText in an object. So basically search for it. So that might be, looking for things like this. And then also looking for streams that happen to have that text in it as well. Or maybe not actually. Yeah, I think it's actually just searching object data. So not searching inside the stream, but searching if this stuff here happens to be defined with the word myText. So for instance, if this is myText was in here, then this would match on it, and it would tell you what object actually had that text in it. And so you could use that for then kind of further programming to try and extract that object or perform some analysis. This is also useful from like a feature extraction perspective. So you can try and maybe have a list of common keywords or common text or common elements that might show up in different objects that maybe identify specific objects as being maybe produced by a known tool or something. So a great example might be to go use the Metasploit attack that you did in the homework. Any one of those exploits that are chosen, if you try and maybe use different EXEs, so like many of you are, by default we were just using the interpreter shell, but you can actually in some cases have a different EXE added on there, or have a different shell that's delivered. So you can basically make maybe 5 or 6 different PDFs using the same exploit. But if you were to analyze those PDFs, you'd be able to identify certain commonalities. So certain objects existing, or maybe a certain number of objects stays consistent or something like that, or the data type of 3 of the objects ends up being very consistent across all of them. You can use analysis like that to try and figure out if maybe, or I should say, you can use something like that to try and use Metasploit to try and train your analysis. So you can search for data in a stream. So this is, rather than searching through the object data here, you you can actually look in the stream data that's between the stream and end stream keywords to try and find text that happens to be in there. You can list objects and their hashes. In this case, it means like checksum, so like MD5 or something like that. Basically, have it checksum all the object data for you. This can allow you to find identical objects across different PDFs, things like that. Extract an object, so this gets you to the point of being able to actually extract the data that's inside of an object. So for instance, if you run one of these and they give you a match, then you can have it go and then extract those objects that matched rather than extracting all objects. It gives you the ability to kind of be surgical in dealing with your PDFs, and it also allows you to not have to, this allows you to bypass having to parse the PDF language yourself. Extract a filtered object. So remember, I'm going to jump up here. You remember that I had mentioned that you can have your stream data actually be encoded or encrypted. One of the neat things that I found with PDFs is that not only can you have it encoded, but there's maybe like 10 or so different encodings that you can actually encode an object, or I should say stream data for an object with. One of the interesting things about that is that you can actually use them on top of one another. So you can actually have like 3 layers of encoding that actually has to be unraveled. And using the filter here, this will help you basically filter it back out to the raw stream data. So you can analyze the raw stream data, or I should say the original data, and then you can also analyze the outer data, or the data as it's visible in the document. It also gives you the ability, so this kind of gets back to the broken PDFs we were talking about, where a PDF may have some errors in it. Basically, some noise might have been introduced for some reason, and if that noise is introduced, then you might end up having to, you might end up having a PDF that you can't really extract all the objects for. So this one allows you to try and extract like the malformed ones to allow you to just look at possibly the broken ones. You can integrate it with Yara. Those of you, everyone had to go through homework 2 so far. So that was to use Yara against the directory of files and everything. This actually allows you to have the ability to have all the stream data actually run against Yara, and then it'll tell you which of the streams actually match the Yara signature, which can be really helpful. So especially if you combine, say, this feature with this feature, you can have Yara signatures written that look for badness, and instead of just trying to run them against the PDF file on disk using the Yara tool, this will walk through the objects, and then it'll run the streams through the filter so that they're actually in the format, the decoded format that Acrobat Reader is going to be working with and acting on. And then from that, you'll be able to scan that stuff with Yara. So you can use Yara to actually find maybe attempts to hide evil within the PDFs. And then finally, it has integration with, or I should say, it offers there's a PDF module. I forget the exact name of the module, but I'll try and get it for the class on Thursday. But it has the ability to generate Python code that would be used for constructing this PDF. And this might be useful, for instance, if you would like to maybe write a modified version of that PDF. So basically you run, the idea here is that if you run this example.py with Python and you have the proper, I forget the name of the module, but it's a PDF construction module. So there's PDF and PostScript and PNG, and all these different modules for the different programming languages. This one, if you run this Python script, ostensibly, or I should say ideally, it would be able to write this example.pdf out to standard output. And so you'd be able to save it to disk. So there's a library for Python that allows you to construct a PDF from scratch if you want, building all the different elements into it. The reason for the existence of that module is so that if I was maybe writing a visualizer in Python or something like that, I was doing some data analysis in Python, it'd be very helpful to me to be able to output the visualization in a PDF compatible format. So they actually use that to be able to try and recreate the PDF from its component pieces. And one of the useful functions of this might be if you want to try and say take the attack PDF and then maybe modify the Python code so that it tries a bunch of different, maybe tries to implement additional features like this into the original PDF. Can you then output a new PDF that still has the attack but has it hidden in a different way than the original version did? And then can you test that against your defenses? So that's a reason for the existence of this feature. And so it can be very, it's a little bit more advanced, but it can be a very beneficial piece. It can also help you with, say, some of the automation and everything. It also gives you the ability to identify the sequences of steps that are going into actually building the PDF in the first place, which can be helpful. Excuse me. Okay. So for the next one, we'll switch gears away from the PDFs, and we'll talk about Microsoft Office software. One thing I will say is that for a lot of what we're going to talk about now, we're going to talk about the Microsoft Olee file format, which is the one that is typically used for files that are ending in the .doc or .ppt or .xls extension, as well as kind of lesser known, or I should say less common file types like .msi and things like that. For those of you who weren't aware, the newer formats that have the 4-letter extensions, the docx and xlsx and pptx and all those are really just zip files. So they're pkzip file format. They also happen to have some specific requirements around what file names are supposed to be inside of the zip. So there is a little bit of a standard that's Microsoft specific around that. But you can actually use any unzip tool to extract any of the newer Microsoft file formats. Inside of the new formats in that zip file, there exist a lot of XML and a number of other file formats as well. Many of the images are just stored in their raw form. But then also, this older Olee file format is actually used in there as well for storing any raw data that doesn't need to be in XML format for some reason, or for which maybe there isn't an XML representation for it. That's why we bring back to that analyzing the legacy Office formats is still very valuable to us, because the current version of Microsoft Office, even though it uses those XML-based formats that have the zip files, it still relies upon parsing this file type for a lot of the binary data stored in there. And I'll be honest, a large number of attacks that have been introduced since those XML formats were introduced, a lot of times are found, the attacks are found embedded inside of those old legacy Olee format files. So, I kind of give an introduction here. Modern Office environments almost always have this suite of programs. A little bit less common, but it does exist, is these ones down here that can all read these file formats, but of course don't use Microsoft's code in reading them, which with the exception of I think maybe one of these two actually implements Microsoft's code. I can't remember which one does. But there's Apache's OpenOffice and LibreOffice. So those two are basically a similar platform. KOffice, some of you on the Linux side might be familiar with. Apple's iWork suite, which is somewhat popular, but I would say in a lot of the different business environments I've worked in, even where Apple is popular, they almost always install the Apple version of Office on there. So Hancom Office is Korean, also sometimes called Hangul word processor for the mainly because Korean character set is much different conceptually and also just literally than English and most of the Western languages, and ditto for Ichitaro, which is the more kind of Japanese one. So like the business environments, I've seen those two used a lot if you have if you do a lot of work outside of just the Europe and Americas. So we'll focus on Microsoft Suite of Software, but it's notable the space is diverse. It's notable that all of these have their own document parsers, and so they each individually have their own set of vulnerabilities associated with parsing the documents. So in broad language, it's very common that something that Microsoft is vulnerable to doesn't necessarily create the same vulnerability in any of these, and each of them may have their own vulnerabilities that are unique to their platform. And that's just kind of the nature of software that's independently written. So Microsoft file formats is kind of where I get, I covered some of this earlier, but we'll just kind of run through it really quickly. I have the delineation that I explained earlier listed right here. So compound file binary, CFB, or sometimes also referred to as OLE, is if your mic is on. So yeah, if your mic is on, or I should say if you're dialed in the class, just mute your line. Yeah, so the whoops. Yeah, so compound file binary is, I think, the official name of the format. The link to it is right here. Those of you who aren't kind of familiar with the history for Office OpenXML, quite some time ago, I forget exactly when it was introduced, but mainly around 2008 or something sounds about right to me. Maybe earlier than that, 2003. It was proposed mainly by a lot of the international community that if there was going to be a document standard that everyone was going to use for electronic correspondence internationally, that document standard had to be an open standard. So technically, Microsoft Office's Open XML specification is actually a public standard that anyone can implement. And so the idea was that, was that there was a fear that if, say, a large company like Microsoft were to, say, go out of business or something like that, and this is kind of on the heels of, say, some of the other big computer-related companies that had decades of existence behind them suddenly going out of business in the early 2000s and late 90s. If the same thing were to happen to Microsoft, it would create could create a problem. It could lock a whole bunch of people out of being able to either edit or read even old data. So they decided to formalize a standard. And actually, I think the one that's there is the one that Microsoft proposed and actually actively maintains as the Office OpenXML specification. This is part of the reason why interoperability between between these tools and Microsoft Office has been a lot better recently is because there's actually an open standard that they need to adhere to. But the specification for the CFB or the Olee format that we'll be talking about is right there as well. Excuse me. So begin with CFB format. It's useful in attacking Microsoft-specific vulnerabilities, as I said. I kind of explained some of the nature of that earlier, so I won't go into why. I will say that from a file layout perspective, the CFB file format is a chunked data format, files divided into sectors. And then there exists the file allocation table that actually define an array of pointers to other locations that map blocks in the file to their ordering within the data stream. So the idea here is that some of the data may be fragmented throughout the file, and you actually have this table that tells you which sectors of the file are used to build stream 0, and which sectors of the file are used to build stream 1, and so on and so forth. This is a very helpful, say that anybody who's done forensics with, say, Microsoft Fat File System or something like that, this might be a familiar structure to you. The idea here is that if you have a file that is expected to be incrementally edited over time, it's very quick to be able to just create a new sector at the end of the file with the new changes in it, and then clear out an old sector in the middle of the file, than it is to, for instance, we'll just go up here and take as an example. In the PDF file format, if there's 100 objects and I want to make a change to object number 20, that means I need to take a copy of everything after object 20, and then I need to add my changes to object 20, and then I need to write all that other data back after my new changes to object 20, because they're variable length objects, remember? So the way Microsoft gets around that is by using a file allocation table, which basically just will associate a new sector to say one data stream, and then it'll allow you to basically write your data into the original sectors that were part of that stream. And then if you actually changed the size of the stream, then you would jump down to, say, a new spot in the file, the end of the file probably, and then you would write more data there. And you don't have to move any of the other data around if you don't touch it. So the only data that actually needs to be moved is the data that is physically edited by the user. This is one of the reasons why saving Microsoft documents and everything, regardless of them being 40 megs or 4 meg or something like that, used to end up being a real fast process. And on computers that had slow hard drives and slow memory and everything like that, it was a very efficient approach to actually do data management. So, and then I kind of summarized that contrast right here. The complication for all of you when you're analyzing these files is that there's a possibility that the components that are used for the attack aren't necessarily going to be contiguous within the Microsoft file format as they would be in the PDF. So similar to the PDF parser, there's actually a number of tools that are useful for navigating the structure and trying to help you recreate the individual file streams into a contiguous and analyzable format from the kind of chunked mapping that is that's present in there today. So said each of them is divided into sectors. So here's kind of a basic layout of the file. So you end up having the top box there I kind of use as like the raw file. So this kind of the box representing the raw file. And then underneath it is all the different pieces. So every single, what it ends up setting up is that every single piece can be as minimum size as a single sector, which I actually have listed right here, that sector size ends up being identical to kind of the original Microsoft file allocation table file sector size that's used on a lot of the disk formats as well. But basically, they end up having header data, and then the next sector, so 512 bytes after that, is the file allocation table. And so that tells you basically, whatever, I think it ends up being a 32-bit file size or something like that. So it tells you which sectors end up mapping to the different streams. So that basically tells you how to, there's a document directory in there as well, file allocation tables, and all that stuff. Almost exclusively, yeah, I mentioned this, the sectors are 512 bytes, which means that you can break the file up into sections of 512 bytes. So here's a good visualization of how the Microsoft Office program or any other program that wants to read this actually has to recreate the file. So you look at this right here as the long thing that's on the left-hand side here. And what I've done is I've actually colorized the sectors according to what streams they refer to. So you'll see that 512 bytes from the top of stream 1 is right here, but then you have to skip all the way down here to get the rest of it. And that's basically what I mean by it's a non-contiguous or sector-based file format. It basically allows you to interleave this data throughout the document. So for instance, if I was to edit, say, stream 2, if I was to decide that I want to clear out stream 2 and I want to add more information to it, I would erase all the contents in sector 6, sector 3, and sector 2, and then I would overwrite them with the new data. And then if my new data exceeded the size of 3 sectors, then it would create a sector number 12 underneath it, basically at the end of the file. And then it would edit the contents in here where I got the arrow, the sector number 0, the file allocation table. It would edit that to then make sure that that mapping is, is present. And so really what ended up happening was I edited, 1, 2, 3 sectors of the file, and a 4th sector if I was adding data, and I didn't touch any of these here, and I also didn't touch either of these. So I only touched the sectors that were part of the data I was working with. So that's very efficient from a perspective of reading and writing data being expensive. It limits the amount of data writes and data reads. Because if all of these were in a row or in line, then I would basically have to move like a whole bunch of data. If I was just adding one sector, I would just have to move like 4 sectors worth of data after it. So that's the reason why they came up with this kind of fragmented file format. So yeah.
What if you end up using less sectors after another?
So if you end up using less sectors, that's a good question. If you end up using less sectors, so let's say stream 1, I end up deciding that, hey, I'm going to delete all the contents of stream 1, and then I'm going to make it so that I just have enough to fill up sector 1 here. So I'm just going to put like 400 bytes in stream 1. So what would happen is that these would be cleared, and then this would be edited to mark them as free. And then the only one that would be part of stream 1 would be this one right here. Again, you don't end up changing the size of the file at all, and you don't end up having to move sector 10 or 11 around to try and adjust for that shrinkage. But then you end up having these things free, and the presumption or the expectation would be that then later on they'd be available if I wanted to, for instance, grow stream 3 by adding like more data to it. Then it would say, kind of a deeper explanation of what happens is it goes from the beginning to the end of the file, it looks for the next available sector. And if the next available sector ends up being past the end of the file, then it just extends the end of the file. But if you free, if you free sectors within the middle of the file, it just leaves them, it marks them empty and available for reuse. So from that perspective, it could hypothetically be considered inefficient. But the way that they'll approach this is that when you save the file again, or when you exit, it may actually, and I think later on, later versions of Office would optimize, it would call it optimizing the file size or something like that. It would actually do the compaction for you, but it would save it for a time, like when it identified you were idle or when you were saving the file or something like that. So basically, when the file was identified to have or to exceed a certain threshold of free sectors or vacant sectors, then it would actually just choose to shrink the file for you manually and basically do the really expensive saving work at that moment. But in other cases, like in older versions of the software, it was not uncommon to actually have files that maybe had a long history of being worked on and actually have like large gaps that are unused in the middle of them. So, but yeah, supporting one of the types that is available in here is basically a free sector. And you can do that, and you can actually, as a common fun thing for people to do back in the day, to have a free sector and then put random junk inside of there as kind of a joke for anyone to do analysis on. So there we go. So I'm trying to remember, do I have this one listed up here? Yeah, so that first link that's on this slide at the decalage.info. So that tool is a very popular one, and it's actually a suite of tools. So it's a package that's built around a number of, around a Python framework for doing Olee file analysis. So these are some really popular tools that are in there. I think there's been a few more added since then. It's under active development still. But you can basically, dump the stream. Here's a good example of, you can get a directory listing of all the streams that are in there and their types and everything like that. So you can kind of get the nice overview or the nice index of the document. You can get the sector mappings, so that whole which stream does this sector belong to. You can get that mapping. You can get metadata about the document. So those of you who worked with Microsoft Office know you can save the file if you use the advanced window or the properties window or whatever it's called. You can put like author name, and you can put like revision number and copyright date and all this junk in there. It's not uncommon for that metadata to also be put into these documents by various tools that are designed for creating malware. So being able to dump that metadata with a tool is very useful, because you can say cross-analyze a large sample set of Olee files that way. The other one, so very similarly to how PDF supports that JavaScript language, which is a full JavaScript interpreter, Office, and many of you are familiar with this, Office has the ability for embedding what they call VBA macros, which is Visual Basic. It's got a Visual Basic interpreter built into it. But just like PDF's version of JavaScript, this one is a specialized version of Visual Basic that gives you direct access to a number of Office elements. So elements within the document, as well as objects that are features offered by the Microsoft Office suite. So it gives you direct access to those things without having to bring in a whole bunch of external libraries. And those things end up being also a nice vector to exploit, because there are some very powerful things that a lot of people put in, like Excel and Word documents and PowerPoint documents. A great example is there exists code for executing programs. So like you can click a button on a document and have it execute another program. That's a feature that exists in Office that they want to make sure that that's available for people to use, because there are legitimate business uses for that. Another example is the ability to write files to disk by name. So you can have Office writing files to disk by name. So that's another thing you can do with it. So I'll say that comparing the two, it's just kind of been my interpretation that Visual Basic's macro assistant, or whatever you want to call it, actually has a lot more features that can be potentially more dangerous if they're allowed to run than, say, the JavaScript that's embedded in a PDF in the PDF interpreter. So jump into the Office XML layout as well. So this is that zip file format I had mentioned to you that exists. So as I said, it's a standards compliant XML language, and you can see that here. The way it's set up is that the file format says that it needs to be a zip file, needs to contain a number of files that are of a particular type with a particular name. So you can see that there's like this word/document.xml, word/styles.xml, word/settings.xml. You also then end up having these rels files, which are kind of like relationships between different objects that are across different components in it. And then there's like this content types.xml. So there's a bunch of these files that are in here that are defined to be in there by the standard. So it's not simply a zip file with XML in it. It's a zip file with specifically named XML files. That said, you can also see that there's, for instance, a JPEG image in here as well. So somebody maybe embedded a JPEG image inside of a document. That image is stored right here and actually has like a index identifier that's defined in one of these other files for it. Possibly this one, or it might be defined in here. So basically, try and use something that has a lot more open standards to try and collect the same type of information together. So one of the nice things is that this is a zip file, so you can analyze it with a normal zip analyzer. Additionally, you'll run into the Microsoft Olee files in here as well, and though this particular one doesn't have one in the list, you might run into those, and they'll typically end in a .dat. You can also embed doc files in it. So just like the PDFs can have PDFs within them, those of you who've played around with Office enough might know that you can drag and drop like Excel and Word into Excel and Word documents and PowerPoints, right? You can also drag EXEs in there as well. So those would all be stored verbatim in here as well. So if you were using one of the newer file formats, you'd be able to basically unzip them and then see the doc files, the docx files, the exe files, things like that, and actually extract them verbatim. So here's some more discussion about the Office macros. So let me just, okay, cool. I just wanted to check where I was. So it supports, the VBA stands for Visual Basic for Applications. So the idea is that they did the same thing that that Acrobat did with the ECMA script or JavaScript. Was they basically took an interpreter. In this case, Microsoft already has a lot of Visual Basic interpreters at its disposal, right? They took that interpreter and they embedded it in Microsoft Office, and then they exposed to it a whole bunch of objects for interacting with the Office suite, as well as interacting with the document itself. So it's a derivative of Visual Basic. It has special hooks into the Office environment, and also the linked documents. So they have, I have a link to an example macro here. I can try clicking on it and see what happens. There we go. See if that comes up. So, yeah, so here's a really good thing. So it already has, in this case, Can't see that. There we go. So as you can see here, there's a class Visio that has a number of things. So Visio is a Microsoft tool, right? So because they have Visio installed here, they have a class Visio that's available to them. And so then they can just go and do things like this. So in this case, this is iterate all through all of the open Visio documents. So for instance, imagine if you're a normal Office worker and you happen to always have a whole bunch of Microsoft Office documents up constantly. Like, I don't know, if you're like me, you might end up having like 4 or 5 documents just open in Microsoft Office. And then someone sends you a fish that has an attachment that has a very simple macro, which is to go through all the open documents and maybe send some information about those documents to some bad place. So, you know, but this gives you the ability to work with the documents. So you can actually dig into the documents and start looking at it. There's like look through all the pages in a drawing, that type of stuff. So you can do that, but it gives you the ability to also interact with the applications. So you can get information about the user's environment. You can also get information. You can drill all the way down to the individual drawings and stuff like that. So it's a very powerful language. And then this kind of shows you what the sample output would have been of that script, right? So yeah, so it's a really powerful language. That's one of the reasons why Microsoft does a lot of research and a lot puts forth a lot of effort. Let's see if there we go. So Microsoft puts forth a lot of effort in trying to you know, mitigate vulnerabilities that are exposed through that without actually defeating a lot of the functionality that's in there that people like. Because again, this is kind of gets back to the conversation we had with earlier with like shared memory and the DDE protocol and things like that, was that a lot of these applications, including this with the Visual Basic for applications, so VBA in Office has been around for a long time. Much of this was introduced at a time when like network-based vectors for attack weren't even like a concept for a lot of folks. So the expectation when a lot of this stuff was implemented was, oh, hey, now that I've done this, now that I've put this Visual Basic interpreter in there, now I can have people write scripts inside of an Office document when they push a button that then goes through all their other Office documents. So now I can tell them to open up these 5 spreadsheets and then also open up this 6th one and then push the button on the 6th one, and then it goes through all the ones that they have open, right? And it does that through kind of inter-process communication. So, you know, that was kind of the, you know, kind of cool feature that now told everyone to do things that way. Now the adversaries know that that's the way that a lot of people do things, and they take advantage of it. But it's very difficult, especially in some environments, to kind of force a different approach to doing the same thing. So, you know, I kind of give some examples right here as well, and I won't jump into every single one of these, but it's a number of different examples where those macros were actually taken advantage of to launch different styles of attacks. So I recommend feel free to go through all those and you know, and read about them. I have this presentation. Excuse me. I have this presentation. Let me do this. Linked right here. So you should be able to, you know, you should be able to go to that, the latest, the topmost link in the lecture notes, and get it. So, and then, you know, view all the links in there. So, and then I'll try and propagate those up as I have time.